So final three talks we'll get in here, and then we'll have a few closing remarks. So next up is Lawrence Chernin, Senior Manager of Data Science at GoGuardian, talking to us about data science, specifically in the education field. So I will stop sharing, Lawrence, and then you can go ahead and share and take on over.
Yeah, hi. Thanks, Jeffrey, and thanks for inviting me. I really appreciate being here and happy to connect with folks offline as well. Sorry I couldn't be there, so I'm gonna go now and share my screen and hopefully that'll work. Okay, here we go. Can you see my screen? I'm just checking.
Yes.
Okay, so for my talk today, here's my LinkedIn link. Happy to connect with anyone and talk about my journey, which is actually almost approaching 3 decades since I left astronomy. So this talk will be a little bit more about my journey than you might have heard in some of the earlier talks. But I'm happy to dig into details about any particular part of my journey as well. So on here, there's an obligatory generated image that shows a little bit of my journey since leaving astronomy and foreshadowing some of the things I'll talk about. So originally, way back, which seems almost another lifetime ago, I studied astronomy, did a PhD, and my PhD was focused on star formation, in particular outflows and jets from young stars. So for my PhD, I did a combination of observing across many different wavelengths, whatever was needed, but a focus on submillimeter astronomy. And also worked in the lab on detectors and devices for submillimeter astronomy. And showing at the bottom is the former Caltech Submillimeter Observatory, which is where I did a lot of my observing. I had at least 10 trips out there over the course of my PhD. And I did a few other things as well. So this shows a little bit more of the other things. Did some numerical modeling and modeling jets and how jets interact with the protostellar environment, built some things in the lab. And so after that, I then switched to doing a postdoc. And I started at Berkeley. I was a Miller Fellow at Berkeley. And I think I missed a slide here. Very much enjoyed Berkeley, moving over to the West Coast, and was very happy to be there, thinking at that time that I was going to stay in academia, given a good postdoc. I had really no intention of leaving when I started academia, my postdoc. But then something happened that started my thinking, changed my thinking. And this was also in the days when if you do get a really good postdoc, you have a good shot of staying in academia. So that's in my intention the whole time, was not looking to any other opportunity, but something changed my mind, or at least got me thinking alternatively. So this came to my attention. Not sure if any of you recognize this person. He recently passed away, extremely famous in the hedge fund industry as having one of the top hedge funds. And so some news came to me here. My thesis advisor at the CFA, was Colin Masson, actually quit his tenured position at the Center for Astrophysics to go and actually work at Renaissance Technologies on Long Island. And I was saying, why would he want to do that? And he really just wanted a change, I think. And so this was in an environment where he gave up tenure and went into quantitative finance. At that time, I didn't know anything about this, but I did research and I've looked at it more over the years. Renaissance Technologies was applying early machine learning techniques, where they were one of the first hedge funds that started to use things like XGBoost, random forest, and pulling all the kind of financial data they could have, building models and trading on that. So after he left, I started to think, well, do I know if I have a future in academia? I'd also lost my main collaborator. And so I'll come back to that. But anyway, I continued with my postdoc, doing everything I could, publishing, joining in as many other groups as I can, networking, all of those things. But unfortunately, what happened after, every year I got into the job crunch, a lot of publications, no interviews, no shortlists. And I thought I have to look for something else. And towards the end of my third year at Berkeley, there wasn't an opportunity for me to stay at Berkeley, even as a postdoc. I had another postdoc lined up, and I started to take a few job interviews of just sort of random people I met through social circles. I had a couple of interviews with hedge funds, but didn't get offers. And I was pretty much getting set to move out to the place where I had my next postdoc, but just randomly met someone who worked in the Bay Area in a high-tech company, which I didn't really want to stay in Berkeley. So I managed to actually just walk into a job back in those days when the hiring was great. They were looking for people with PhDs. And so I stepped into the semiconductor field. And this is a long time ago. These are the kind of things that I stepped into. And when they interviewed me, they asked me questions about this stuff. And I told them, frankly, I don't know anything about this. I thought, well, I'm going to just destroy any of my chances of being hired. But they were perfectly happy to hire me and gave me the first 3 months really to get up to speed and learn everything I could about the processes involved with semiconductors. And here on the right, I show like a high level view of chips, small chips, and then their layouts, how chips look, with the different layers shown on the left side in the different colors. So I learned a lot about that, and especially the software side. There's a lot of software that's used to automate the design, check the design, generate designs. I joined that field. There were a lot of actually physicists working in the field, and the person who hired me was a former physicist from the Soviet Union, who was just intent on hiring as many PhDs as he could. Back in those days, they needed to fill spaces, like the building cubicles were empty. They needed to hire people. So I managed to walk in there and work in this field. Here's a few more screenshots of what I did. Things like looking at current signal performances in these chips, actually the physics of the devices. And there were a whole range of things. I worked in this domain for over 10 years. And over time, I saw that this domain was changing a lot. And so I needed to then think about my next pivot, because things were not like they were at the beginning. And so I was looking for something else. And I also wanted to do my own startup. So after about a decade doing semiconductor software and algorithms, I decided to do a dating site, which is something I wanted for myself. And you had a previous talk here about Tinder. The idea I had, this was back almost 15 years ago, was to just build a dating site, and I copied what essentially was done on Plenty of Fish. And so I did it all myself, wrote the software, put it up there. I landed up getting about 45,000 users, which was okay, but it wasn't really financially viable. What I found was that I had missed the opportunity that Plenty of Fish had with the Google ad marketplace. When I just started and I had my dating site launched, user acquisition costs, believe it or not, were 20 cents or less in bulk, because people hadn't discovered Google AdWords yet, or businesses hadn't discovered them. But that quickly changed, and customer acquisition costs now are many, many orders of magnitude higher than that, depending on whatever industry you're in. So that sort of killed that effort. And so I had to look to do something else. So after 3 years doing the dating site, which I was really involved a lot in software development, I thought I would get back into the semiconductor field. And so I had an interview at the former Sun Microsystems, which is acquired by Oracle. At that time, I was living in Manhattan. And so they agreed to fly me out back to California to get this interview. And I had the interview. I had a few extra days in California. And I just like randomly sent in my job application to a company that was developing games, which was actually Disney Interactive. And so I applied there because I thought, well, maybe I could do some game programming. That would be more fun, perhaps, than going back into semiconductors software, which looked like it was like fizzling out, at least in the US in terms of innovation back at that time. I didn't know that it would have a giant rebirth for data centers and AI chips. I didn't know about that part. So I was looking to get out. And luckily enough, I got hired at Disney Interactive. And these are some of the things they were doing, which are building social games. And they said to me when they hired me, well, we don't think maybe you're what we're looking for as a programmer, but maybe we can hire you for this thing called data science, which I again said, I don't know what that is. And they weren't deterred. The person that hired me also was a former physicist who had his PhD from Berkeley. And he said, we just want people with PhDs. So I had a chance to kind of learn data science there. They built a lot of models for understanding customer acquisition costs, as well as engagement and performance of advertising. It was really like business intelligence focused, which I wasn't like super enthusiastic about, although I did really enjoy working at Disney. And so I had, which I mentioned there, sorry. I really stepped into that job like I stepped into the semiconductor field really by accident. And so there I finally did my pivot again into something I was really passionate about, which was education. But I would mention that as this was starting my journey in data science, I spent a lot of time on Kaggle. You can see here I've like competed in almost 300 competitions. And this was one of the great ways I found to like improve my skills and tackling competitions in almost every domain. Some of the competitions I was very close in the end, but just couldn't make it into a prize position. So then I got into education. I worked in a couple of startups before, and I sort of improved my skills in breadth. I enjoyed startups. I picked an education startup that was really small, and this was almost 10 years ago. That startup landed up being acquired by GoGuardian. So I switched into educational technology. The focus is on improving learning outcomes. And then there's many different aspects that I worked on, from personalized instruction, identifying at-risk students for intervention, giving data to administrators, and a big one, which is the kind of thing I work on now in my day-to-day, is usability. We have a product that has 100 features and knobs and buttons on it. It's great for the established users that have mastered the learning curve, but we want to make that simpler and easier to use. And given that I was in the small startup, I really had to do almost every role, from talking to customers, thinking of new ideas as well, and building reports, doing data science, data engineering, business intelligence, writing software, doing back end, even a little bit of front end software, doing a bit of everything, which you have to do if you're in a startup. That's small. There's no boundaries. It's chaos. It's not for everyone. Now, when I talk about educational technologies, it's a vast space. So just showing that, and even if we go into breaking it down by the K through 12 space, which has been my focus, many companies, many different products, and it can even go on like this, breaking down further. So it's a vast domain. And the company I worked at, the product was called EdgeElastic, which is an assessment platform. And EdgeElastic was acquired by GoGuardian in 2020. GoGuardian, now it's a unicorn startup. It's in about half of the schools in the United States, at least one of the GoGuardian products. There's a product suite. And it had a lot of employees, vast growth through 2020. It acquired three small startups. GoGuardian was itself a startup, but it was immensely successful and was able to acquire smaller startups. So that's how the startup that I was at got acquired. And then after the acquisition, an interesting experience. There was a lot of turmoil in the sense of how do you integrate these new startups into a coherent product offering and a coherent team? And it's taking a few years to resolve, but it's still kind of in a state where I'm back to where I was in the small startup, in that I'm involved in almost all of the pieces from, data engineering, data science, also subject matter expert, and even product management. And that's the way I kind of see my role, as being able to do all these different things, given my years of experience, not so much focused on one specific thing. And I have a small team. So part of that is managing the team. Another part of it is actually doing a lot of the work myself. So here's examples to give you an idea of my day to day. In an assessment platform, the educators can create different kinds of questions. Here where they like fill in the blank, they can actually do math. There's like LaTeX. They can type it in the editor. There's also evaluation of equivalent mathematical forms. They can do parameters in these math expressions, charts. All of this is graded automatically. And so that's the advantage to teachers, and they get all this data out. And I should mention, this assessment platform has millions of users. There's, in a typical month, there's many millions of users, which is kind of amazing to me, because we're like a small team, and then we have all these users. And sometimes it's interesting to look at like the Google Analytics map of seeing all the little bubbles of activity all over the place. And that's part of my motivation for seeing the impact. And here's another kind of example. There's a lot of data. It gets sliced in different ways. I spend a lot of time looking at reports like this and pulling the data, crunching the data, cleaning the data. And it tends to get, those first few slides are marketing slides. When we get, this is also still marketing slides, but you can see like the complexities increased. And it can be overwhelming for a teacher, maybe not a school admin. So a lot of part of my role now is how do we simplify the user experience? And here, even further, when you get down to details, I look at this and I even get like overwhelmed with the amount of details. So this is my current day today, is how do we improve the user experience for all teachers in all subjects that want to use this platform? So, but now I have a side project. People who are kind of obsessed with startups, this is what happens. So my new interest is actually in the medical domain in healthcare, which I'm dabbling on the side, and in particular, this cognitive impairment. So I really spent the last 3 years learning everything I can, talking to doctors, reading papers, and this picture in the top left, I first thought this is something from astronomy, but it's not. It's brain disease. And I've been trying to understand where I could be impactful in this domain. And this is what I see as like my next step, because, I pivoted many times. And what I would encourage people, there's a lot of like very, very challenging problems in healthcare and medical science. It may be hard to get in, but if you spend enough time researching and studying, understanding the domain, there are a lot of startups, there are a lot of opportunities. I'm happy to connect with people. Although I still work at GoGuardian, this is where I'm working to next. And for example, if you go through a test in cognitive impairment, if you pardon my sense of humor here, this is the standard for the last many decades. There's the Montreal Cognitive Assessment. This is an absurd version of it, but it kind of asks you to connect numbers, subtract 7 from another numbers, remember words. This is not the way people should think about measuring cognitive impairment. And this is the particular domain that I've been interested in. Um, so this summarizes my journey again, all over the place. I'm happy to talk to people if they're interested in this medical area, because that's something I'm working on towards getting funding and applying for grants. There's a lot of opportunity. But in the meantime, I continue working in the educational domain. So thank you. Did I stay within my time? Yeah, I think pretty much.
I think we have time for maybe one question. Going once, going twice. All right, anyone online? The question?
I have nobody here, but I could pose one. This
Go for
is a fascinating journey that you've been into. I'm very impressed because
Thanks.
it seems really varied. Do you think that's possible still these days? Like a journey like yours could still happen in the current environment?
That's an excellent question. I think it's harder. The situation has changed. Back when I started, there were a lot of opportunities. Like, as I mentioned, my thesis supervisor, he really just stepped into quant finance, who, was hiring like crazy. So, and when I stepped into the semiconductor field and into Disney, they were looking for people with PhDs. It didn't matter what you knew. Now you can't, getting hired into data science is super hard on the first job. It's almost impossible. And so I think it's good to kind of network and look where the opportunities are. I would encourage people if you feel like you could work in the medical field, it's not for everyone. I've spoken to a lot of friends who will not like touch this domain at any cost. If you're like really passionate and mission driven to do something in healthcare, then of course it's different. And so I enjoy doing this, and I would encourage others because there are a lot of opportunities. It's definitely less competitive than it is in the general data science field. So I have applied for grants. Getting those grants is not as hard. I mean, in terms of like just number of applicants versus the number of funded. I don't know what the stats in astronomy grants are, but compared to getting like investors, it's easier to get grants. I mean, getting investors in any startup, getting grants to do like Alzheimer's research is a lot easier just in terms of the numbers and amount of funding that's available. So there are opportunities.
All right, let's thank Lawrence one more time. And our next speaker, who's making his way up, is Stephen P. Janowiecki, engineering specialist, Aerospace Corporation, talking about from astronomy to aerospace, so switching domains here. So stop that, and we will pull up your talk. And there it is, and it's a PDF, and I need to go back to sharing my screen. Okay. Click some buttons. And did it again. I keep doing this today. One more time. Here we go. Big green button. There we go. Double screen this. Preview view. There, that looks better. Let's see how that goes.
All right, great. Thank you. So yes, I'm Stephen Janowiecki. I'm here with colleague Nicholas Chapman from the Aerospace Corporation, and we're here to tell you about all the great things that we do at the Aerospace Corporation that we can tell you about. I think as other folks may have mentioned, this is my personal views. Obviously, I don't speak on behalf of the Aerospace Corporation, and I had to get all these slides. I had to use approved slides, so I will speak maybe a little beyond just the slides. Like, I don't have a bio slide because I didn't get that approved in time. So I will just tell you, I did a PhD in astronomy at Indiana University in 2015. I did a lot of ground-based observations, optical observations. Did a postdoc in Australia doing some radio and optical observations, and then worked at the McDonald Observatory in Texas for 6 years, running a 10-meter ground-based optical telescope. I love observatories and telescopes, and I still get to do a lot of related work at Aerospace. But it was a sort of a natural time for my family to move back out of the West Texas desert to civilization. So it was a good opportunity to move to the Aerospace Corporation for me. And our group at the Aerospace Corporation has several folks who are former astronomers now working there. I also, as Jeff mentioned, I wanted to acknowledge that we are not data scientists, at least in my group, so thanks for including us anyway. I think it's still a place where astronomer skills are really valuable, and we do a lot of data-related things, not data science, but anyway, I'll tell you a little bit about why I think you should consider the Aerospace Corporation if you're an astronomer looking for something else to do. How do you recommend advancing? No.
No, I got it. There we go.
So I also brought some shiny corporate slides to talk about all the great things we can offer. It is an exciting place to work. You can talk to me or Nicholas more about that. What was I was going to say? It's a little bit in between academia and the corporate world. We're sort of a midpoint between those. So I put some background about the company here just to make sure you had heard of it. So Aerospace Corporation is a federally funded research and development center. That may be an unfamiliar word to a lot of astronomers. I didn't know what that was, but so is the NRAO and Los Alamos National Lab and all kind of NOAR Lab. These are also run as FFRDCs. So Aerospace is in kind of what I would think of as good company with a lot of astronomy-related groups. So it's federally funded, and it acts as a trusted advisor to the government to help solve some of the hardest problems. Aerospace is the only one of those that is entirely focused on space, so we do a lot of space-related things. Our headquarters is out by the Dulles Airport in Chantilly, so not too far from here. We've got tons and tons of technical experts. I think a quarter of the company has PhDs. It's a lot of really smart people figuring out hard things to do with space in a very general sense. It's a nonprofit company as well, so ultimately our product is the advice that we give the government, and we're not, making money at the end of the day, for better or worse. So we help with the focus areas listed on there. We help government, civil, commercial, lots of different customers. And we have more locations. I thought I would we're not just in Chantilly. There's a really big Los Angeles, sort of our lab campus is there with lots of laboratories, but then other locations around the country where Aerospace has a presence. So the problem I wanted to talk about, the sort of cool example, I don't want to tell you how many employees we have and all the boring statistics, but the problem that I work on and that our group works on has to do with sort of changes that you've probably heard about in astronomy. It can be kind of a negative thing with a lot more stuff in orbit than there was in the past. Space is getting crowded. There's a lot of increased activity, and for reasons that you could imagine, a lot of government, Air Force, other people want to know what's in orbit and where it is and is it changing, right? I don't think that's a surprise to hear that we're interested in knowing that. So we call this generally space situational awareness or space domain awareness. So this is just learning where stuff is in orbit around the Earth. I guess it's sort of obvious how you might do that. You could use radar, where you bounce an electromagnetic pulse off of a target and it comes back, and that tells you exactly how far away it is, but it doesn't really localize it very well depending on your radar dish and how precise you can get a position. So it's often common to use optical as well. You've probably all seen a satellite going overhead at night in the sky. So that's the basic concept. There's a small telescope there that Aerospace has out in Los Angeles that is sort of used for space situational awareness and testing things. And then there are obviously telescopes in space as well, not just the astronomy ones that are used to look at other objects in space and figure out where they're going. So my group works a lot on the optical space domain awareness. So to sort of translate from astronomy, if you all have ever used a telescope to look at something in the sky, you probably tracked at the sidereal rate so that you compensated for the rotation of the Earth, and the stars all made nice point sources, and you looked at a galaxy or a planet or whatever. We often will do a rate tracking mode where you track the target of interest. So that's what those pictures are showing over there, where the one on the left, the stars are fixed and the target has drifted. Or if you know how your target's moving, you can track on the target and then the stars drift. So you can do better measurements of your target if you know how it's moving. Just a little connection. If you've looked up at the sky from the ground, you also know there's lots of backgrounds that you have to contend with. Same thing if you're trying to look for satellites. I know in astronomy we try to look around the satellites and avoid them, but now the satellites are the interesting thing. So just like astronomers deal with different sources of background, so do we have to deal with, even if you're dealing with a space-based telescope, the galaxy is still there, the zodiacal light is still there. You can get scattered light, I think I've talked about, right? If you're looking from orbit, looking near the sun or near the Earth, the sunlit part of the Earth, that can give a lot of stray light in your optics. And so you have to think carefully about the performance of your imaging system and planning all that out. So, and lastly, obviously when you take images, you have to calibrate, reduce the data, calibrate the data in all the same ways that anyone who's used a ground-based optical telescope has experienced, with biases and darks and flats. And so we go through the same kinds of things, stray light removals, but with a very different application. And you'd be surprised sometimes you have to really convince people that you really do want to do a dark image. Like if you haven't done this before, you might not think it was that important, but no, you want to do this. So we're fighting the good fight. But often our targets are really interesting and different. You have unique problems, like you get eclipses from the Earth's shadow. So if you're watching a target that goes into eclipse, its light curve can change really dramatically and in strange ways. But anybody who's looked at stellar or astroseismology or stellar pulsations have seen some pretty weird light curves too. So astronomers are good, I think, in all of these areas. But what I wanted to tell you about specifically is a product that or a software tool that we've developed really before I got there, so I'm speaking on behalf of the team, to do simulations of space telescopes, or we call them sensors, that don't yet exist, but might exist. And this is kind of one of our core business things, where someone comes to us and says, hey, we're going to build a thing, it's going to be like this, what will its performance be? And we can simulate what that performance will be, which is an important decision-making piece of information that they might need when deciding whether they want to buy it from this contractor or that contractor or whatever. So this is called a scene simulator, where scene just means an image, in this case, a picture. And if I had made this a real PPTX file instead of PDF, this would be animated. So if you can just imagine the stars are streaking past, and there's a little target sitting right at the center that's not moving. So, okay, that's the only animation that I didn't include. But so this is a tool that takes into account what kind of target are you looking at, what kind of orbits are you in, what kind of orbit is the target in, and then what kind of optical system are you? Are you a big telescope or a small telescope? What's your CCD like? It includes all the relevant backgrounds into obviously the background of the image, and read noise and gain and all this stuff, and then it produces very realistic images that you would get from a system that does not yet exist. So some of the cool features that we have in there is that you can plug in lots of different kinds of targets. It could be a theoretical sort of target, like a sphere that reflects in a perfectly diffuse way with no features anywhere. Or you can put in a CAD model of exactly what the satellite is and what it's made of and everything. I think the plenary talk this morning, he mentioned, I think everyone's used the Gaia Star Catalog, and yes, so do we. We use the Gaia Star Catalog as well to populate all those background stars. The PSF of the optical system, whatever model telescope system you're building, is included to get the pixel phasing right. So this is an example of pixel phasing. I hadn't encountered pixel phasing in astronomy before because usually astronomical telescopes are oversampled. Like you get at least 2 samples per full width half max. But in a lot of these cases, the focal plane is undersampled. So if the star moves within the pixel, things can really change the light distribution. So that's handled correctly. We do color corrections. Imagine explaining to like someone who's not an astronomer what a color correction is. But to match the bandpass, right? Because Gaia observes in a certain bandpass, and this instrument is in a different bandpass, and so you have to compensate for that. Right, all the background sources, the diacal light, everything gets modeled in there, and it can, we have like an interface to build up like a whole concept of operations, like what are you going to do with this for a whole month, and what are the data products going to come out. Then you can plug in, I don't know if I put it in here, you can plug in all that information and you get this really nice image out, and you can then test like downstream data processing pipelines on the images. So before the telescope system or whatever is actually built, we're getting like a month's worth of simulated data for somebody, and they can run it through their processing pipelines and see if they get the quality they were expecting to get out of it in the end. So this is an example, a rich image that shows a lot of the interesting features. This one is rate tracked, so it's following the target in the center in that green circle. And there were 3 other targets nearby. These are like satellites orbiting kind of close to each other. You can see there's some simulated cosmic rays in here. There's some simulated bad pixels, bad rows. There's stray light, obviously a lot of light coming over here. That's the Earth off the field of view, giving that scattered light. So it's a very realistic simulated thing. And we've done some ground truth data to check that it's really matching up pretty well with reality. I put this link in here too. This is like, I got excited about this. This was presented at a conference last summer. And there's like a publication. So like a lot of our work, for obvious reasons, doesn't end up getting published as such. But if you actually want to read it, it's a really detailed paper, conference proceeding on how this tool works, what it takes into account when it generates simulated data, and how it's used in a theoretical sense, not specifics. So that's my exciting angle for astronomers at the Aerospace Corporation. There's lots of other things that the Aerospace Corporation does beyond things that astronomers do, but space domain awareness is a happening place. This was a slide that my colleague Chris Griffith presented here at this ATDS meeting last year. It's still true this year. There's a lot of growth in this area. We're hiring astronomers in our department, and there's a lot of interesting problems to solve beyond just the astronomy related things. My favorite are the satellites that look up, or at least out. A lot of people use satellites to look down as well, and that's cool, and there's some interesting work in geospatial imaging. Our labs have a lot of work. We actually will test new sensors, new CCDs, new cameras, characterize those, and then use that to model better what we're seeing, what we're predicting. And there are folks working on machine learning and data science at the Aerospace Corporation, but I'm friends with them, but I don't know exactly what they do. We have like a matrixed support system. This is a corporate chart, if you couldn't tell, where there's like half of the company are technical staff in these different areas, electronics and data and things, and then we all sort of get assigned out to different programs and help work on different areas as those things come and go. But it has, I would say, like a really university sort of feel where there's like departments of experts on different subject matter. So if you need someone to help you with a propulsion question, you go over to the propulsion department. If you need a crazy orbit that can get you from here to there with only this much fuel, like you go talk to the orbitology people. And when they have a question about like, oh, how can we set up a camera that does this, imaging campaign or something, they come to us and we help with that aspect. So it's a really collaborative environment with experts on sort of every aspect of space. We have an internship program. I think that deadline is coming up pretty soon, but if you're interested, we're advertising some internships. They're paid internships over the summer, which is a great way to get your foot in the door if you're a student. I just searched our website. I didn't think I needed approval to post a screenshot of our website, but I searched our website as of the end of last year, and there's a whole bunch of jobs that list astronomy in them. A lot of times it's like, oh, if you have a degree in physics or astronomy or whatever, you would be a good candidate. Our department in particular in Chantilly has a couple of jobs posted right now, which is why I have my little I am hiring sticker on. So if you're actively looking for a job in aerospace, come talk to us about that. We are advertising those. And yeah, so I think it's been a really, I didn't tell you, it's been about a year that I've been there, so I think it's a relatively recent perspective that it was a really positive transition to make out of astronomy and into the aerospace industry, but made a lot easier by the fact that a lot of other astronomers are in my group, and so even at the interview, we could all sort of speak the same language and say, oh, magnitude file, FITS files, oh yeah, okay, right, Super Mongo, yeah, okay, like everybody knows some of the common language, but yeah, it's been a really good place to work. I mean, yeah, that's all. Yeah, happy to take any questions or talk more.
Right, I have a question back here.
For the corporation, how does the funding work? Is that like an annual renewal through the government? Is that like a multi-year contract, or?
Yes, it's from Congress, which is, you know, the smoothest and easiest process of funding ever. But we've existed since the 60s, I think? 1960. So it's not like in question as to whether the funding will be there in the future. There's a lot of agencies that are relying on us for things. So the funding model is really complex, and it has to do with making sure we don't end up competing with the private industry, like for consulting advice and things. So we're limited as to how many total people we can have, but it's been very steady and consistent. As far as individual projects go, then like a customer, like the Air Force or something, could come in and ask for a certain amount of our time, and that can come and go on shorter time scales. But like we're funded by Congress essentially in the long term.
Since you brought it up, I'm going to sneak in half a second one, which was mostly, is a lot of your work essentially task-based by clients, or do you have like independent stuff you do as well?
It's a little bit of both. I think of it, our group talks a lot in terms of like analysis tasks and development tasks. So like an analysis task is someone says, here's a future system, will you help us evaluate it? And a development task is like, hey, we get a lot of requests for this, can we build a better tool to do that? And so there's different ways to fund both of those, but it's maybe not quite 50-50 between those. It's probably a little more on the analysis side, but it's nice to have a mix. And then within our group, we can sort of distribute like, oh, this person's really good at software development, like they're going to go work on making the tool better, and this person's good at writing up the summaries or whatever. We can work within that. So it's been fun.
Any more questions here in the live audience? You've already asked 2 questions, sir.
Just out of curiosity, how large are the teams that you normally work in internally?
Our department is one of the bigger ones, and there's probably 20 people in our department. Is it bigger? I don't know. I'd be smaller than that, but 15 people in our department, maybe? So? Yeah. We're sort of functionally organized around different projects or different tools, but then there's a lot of people that you sort of use when you need them, like reach out to your contacts in there. But like day to day, there's probably 5 or 6 people I see regularly. I don't know. Yeah, good question.
So those of you who are interested in this work, like the Amos conference, it's held in Hawaii every year in September, and it is all about space domain awareness, and it is very critical for national security. So if you are interested in this topic, I really, urge you to check that out.
Yeah, most of the interesting material I presented here was from the Amos conference.
Yeah, thank you.
It was approved already for that, so yeah, it's very interesting.
We have do we? Oh yeah, do we have any questions online?
We don't, but I have a small comment. Hi, Steve. Nice to see you. I think this is a story where you should probably use the fact that what used to be your garbage is your data now. I think that's too cute and too funny not to say more often. I think it's great. It's a great story.
Yeah.
I think there was one more.
Yeah, just a quick question. So as a current student who's maybe a bit nervous about making the jump from academia to industry. It's very comforting to hear you speak to how, you know, it's more university-like environment, because that's the kind of environment that I feel like I work best in. You know, like, I feel like it's collaboration, you're on a team, you're working with other people towards one goal. Can you say anything to, about if you were to, you know, when you first got into the job, would you say you were like, was there a training period that you felt you were mentored through? Or were you just sort of thrown into the fire as
No, there was a sort of a long and intentional training period. I don't know if that's just because of our sort of group's director is very thoughtful about the way she brings in new staff members, but there's two things. One like there was an expectation that I would have a learning curve because I didn't have the background, you know, in satellites and rockets and all that stuff. But there's a lot of internal trainings that the company offers to do those. And the other is that just sort of the way it worked out, like you assume when you start working for a company like this, you may not have a security clearance. And so your access to certain material would be limited. And so you're doing more like general kinds of things at first. And that's really a good training opportunity because it's just like a little slower paced and you're able to broaden. And then later, as you get more access, you get more specific. So it's kind of like grad school where you start out with sort of the classes that are broad and then you focus in on the specific tools and areas. But yeah, I found it a really welcoming and friendly place to learn and come up to speed. So, yeah.
Stephen again.
All right, we are, huh? No, right there.
The last talk of the day is Kyle Penner. I'm getting him set up here.
Show the headshot, be fun. Make it for everybody. So yes, there we go.
The talk will be, I left academia, but not the precision photometry community, data science in the US government.
So yeah, another domain talk, this time about government. And we'll stop that one. And we will switch over, not to that one, to PowerPoint today. Excellent, okay. Put that up. We will share, see, that. There. Looks like it's working. See, I'll figure it out by the end of the day.
All right, thank you. So you've heard lots of talks about data science. You just heard a talk about doing astronomy, but not data science for the US government. I'm going to talk about both to the extent that I can. All right, so a few disclaimers to start off with. I am not a US government employee. I have never worked for the US government. Previously I worked for the US Navy's FFRDC, known as CNA. That was my first job outside of academia. And then I moved to Booz Allen Hamilton, and now I work at Expedition Technology, which is a small company. In parlance, I'm a defense contractor. I am not a US government employee. I'm not an FFRDC employee, which is this weird status that's in between government and contractor. So I'm a defense contractor. I have been a defense contractor since I left CNA. These are my thoughts. The things that I'm gonna talk about, so I'm gonna talk about 3 projects, 2 of which are unclassified and 1 of which I will tell you very little about. To work in this line, to do this kind of work, you need to be a clearable US citizen. There are lots of factors that go into getting a clearance, into whether a person is granted a clearance. Very few individual factors like immediately disqualify you from being a clearance, from getting a clearance. So that clearable is kind of a scary word, but I argue it should not be. But you have to be a US citizen. So 3 projects. So a bit about getting the clearance. in the contractor world, in the defense contractor world, the company most often wants you to have a clearance coming into the employer, which is sort of a catch-22 because you need a job that requires a clearance before you get the clearance. So FFRDCs are often willing to sponsor clearances. In the contractor world, it's very rare to find a position that will sponsor you for a clearance, but it's not unheard of. Expedition technology, when we have the right projects open, we are more than willing to sponsor clearances. Oh, and another thing, just I guess if you have a question, interrupt me. I'm more than happy to take questions as we go rather than at the end. All right, so this is the thing I'm going to try and convince you of by the end. Like, I am really happy. I get to do lots of different types of projects. Some of those projects are like astronomy, and I put astronomy in quotation marks because I'm not doing, like, Alex Pope, who gave the plenary earlier today, was my first advisor. Like, I'm not doing the astronomy that I did when I was working with Alex. I am, but the astronomy knowledge that I have is very useful, very useful. It's a very niche, very important for national security kind of knowledge to have. So I get to do it occasionally. Like, I've done a project that involved astronomy. They're hard to find outside of places like Aerospace that focus exclusively on space domain awareness. But they do exist. Yes, so I'm happy. I get to live in this area, which I am happy about. I really like the DC area. Like tonight, I'm unfortunately, instead of going to the happy hour, I'm going to the Moth Story Slam, which is in DC. So I gotta head out there. So I like this area. I get to live in a place where I like. So I guess a bit about my journey. I got my PhD in 2014 from the University of Arizona. Mark Dickinson was my advisor, PhD advisor. Then I did a postdoc at CEA Saclay outside of Paris. And then I did a postdoc at NRAO, an astronomy FFRDC in Charlottesville, Virginia. And then I left. So like, I really enjoyed living in Paris. I did not really enjoy living in Charlottesville. So like, being able to live in a place where I want to live and that has all the activities that I like to do at a salary that affords me the opportunity to do those things is quite nice. So all of those things. On to the first project that I'm going to talk about. This is an unclassified project. This is a bullet point from my resume. So the first project, or one of the projects, is trying to determine the factors that increase the probability of an aviation ground mishap. So the Navy has planes. These planes are often on the ground. When there's an accident on the ground, like say a maintainer, a US Navy sailor is working on a plane and drops their tool into the engine of the plane, that's a ground mishap. There are many types of ground mishaps. Ground mishaps can cost the Navy hundreds of thousands of dollars. They can cost lives. It is important. The Navy was very concerned, and it's very important to try as well as we can, as well as we could have, to determine the factors that increase the risk of an aviation ground mishap. So when I worked on this project, what year was this? 2019. Yes, 2019. We were not doing anything with artificial intelligence. There were no deep learning models, no neural networks. I didn't go anywhere outside of things implemented in scikit-learn. But it was important work. As I mentioned earlier, we were trying to, like, ideally reduce the risk of people dying. But let me see if I can, no. I have my notes. Anyway, so aviation ground mishaps, thankfully, are rare events. So this was a hard project. We're trying to determine the factors that increase the risk of a rare event. So that's like, it was important for this project to know the limitations of machine learning. It was important to be able to communicate that to our sponsor, the people in the Navy who paid us to do this work. So like, the first thing we did was, let's make a neural network, like a very basic neural network that we can assemble, not from PyTorch or whatever, but from like elements that already exist in scikit-learn. So we made a neural network. We tried to throw some features into it, predict the probability of a mishap happening in a given month. It didn't work. Like, it's really hard. They're rare events. We didn't have very much data on these rare events. Feature engineering is really difficult. Like, you can think, oh, like if the maintainer doesn't have a lot of sleep, maybe that's a feature that should go into the model. Maybe a lack of sleep increases the risk of a mishap happening. But how do you track a sailor's amount of sleep? Like, you know, right? So feature engineering, so the neural network didn't work. In the end, we switched to a Poisson regression, and we just did as best we could. This went in, it's important that we tried. We did not succeed in finding any relevant features that could have reduced the risk when I worked on this project. I think other people inherited it as it went on. But it is important that we did this and that we told the Navy, like, we did this thing, it didn't work. Maybe, like, it won't work. Any questions there? Cool. So this is the project that I won't talk very much about. So this is the astronomy project. We did do data science and astronomy. We use these computer vision models. This project ended about 6 months ago. It ended right as YOLO V8 came out. So we had all sorts of model upgrades depending on customer input and things like that in mind. But one thing about working as a defense contractor or for the government in general is sometimes the funding dries up and you can't finish the project. So it was sad that this project ended that way. But we did, like, I did run source extractor. We did simulate, we did use a scene simulator. We did simulate images. We did use Pan-STARRS data. We did, like, use real data as well as data that we simulated. I did run source extractor on it. Source extractor ended up not being part of the production code, but it was very useful for validation. So, and then we fine-tuned these computer vision models, faster RCNN and YOLO V5 on them. As you have learned today, former astronomers, we are everywhere. We have, like, infiltrated the government everywhere, including, like, I have some friends who actually are civilian government employees. So government is one of the few places where you can do astronomy, as you just saw. Like, radio astronomers who know digital signal processing techniques are really valuable. And it's kind of fun to walk into a military office and have, like, the officers call you the space person. It's like, and they'll want to talk they wanted to talk to me about like black holes and like aliens and stuff like that. It's fun. I was an observational astronomer. I went observing a few times. I remember a time that Alex and I went up to the Caltech submillimeter observatory. So I have a love-hate relationship with observing, but like I have been on testing events, and I have been at exercises, and doing government work is one of the few times, like I haven't seen this in any tech data science, for example, where you go out into the field and like look at the thing. It turns out knowledge of sensors is really useful. Like I don't know how GPS works. I don't know how a GPS sensor works, but I can start to acquire that knowledge. And from the basics that I know, I just have so much, that much more beginner knowledge of how GPS works, and so like that's a good jumping point. So I don't want to paint too rosy a picture. There are some cons to government work, as I mentioned, like funding can be one of them. On this project that ended prematurely, something happened. We were under contract with the government to do like a 2-ish year project. And our funding came in increments, and one day there was no increment. The increments stopped coming. So, and it was because there had been a reprioritization of government funds. You know, that happens. There are some other cons. You can go to prison if you say things that you're not supposed to say. If you're working for a tech company and you say something you're not supposed to say, you get fired. So there's downsides, right? Either way. So a big one that is very specific to government work is the classified internet sucks. Uptime is a real challenge, except for AWS. AWS on the classified internet works great. And the final one is if you don't like your coworkers, you're stuck with them in a confined space, which is maybe not a thing with all the companies doing return to office right now. But you know, find coworkers you like. Any questions about that? All right. So what am I doing now? 100% of my time is for this program, our EXP's solution to this program called Haystack. It is a, what is it? Normal human movement across times, locations, and people. So when I moved to CNA, and then Booz Allen, and then EXP, when I initially moved to CNA, I started I was on the submarine warfare team, and I started doing geospatial analysis. I started leaning into that. I really liked working with geospatial analysis, like all the open source Python libraries like Shapely and PyProj and things like that, using all of that. It turns out I am really, I just like working with like set operations, like intersections and unions and things like that, and it's fun. You know, GIS is all just a 2D set operation. So that work in geospatial analysis, or that emphasis that I placed early on in my career, led to working with human mobility data. So this is what led me to working for EXP and on this Haystack program. So how much time we got? Oh, 10 minutes? Yeah, okay. The Haystack program aims to do privacy-preserving anomaly insertion and detection of anomalies of agents in a big simulation. That doesn't make any sense, right? So I'm gonna try and explain what actually happens. There is a company, a performer, we call them performers. There's a company out there that simulates, let's say 500,000 people, agents. These are simulations of agents moving around a city. So there are 500,000 agents, 500,000 agents times a month of data sampled at once every 3 seconds. It's a huge amount of data. We receive those simulations, the training period of those simulations. We try to learn on an agent basis what is normal, what those agents are doing on their normal lives. So remember, these are simulations. So like there's an agent that's possibly moving between home and work a bunch of times over that month-long period. So we try to learn what home and work are and when those transitions happen. And then we receive the test data for a simulation of a different month for those 500,000 agents. And we are told by the government, make these agents do these anomalous things. So the government has found that that agent that goes only between work and home, we now have to insert a trip to a McDonald's or a Starbucks or whatever. Some anomaly that the agent has not done before. It might be like the agent has to return home at an unusual time. Anomaly could really mean anything. We try to insert that anomaly into the test data. So remember the training period that we have learned normal from, and then we receive the test data. We make an insertion into the test data. Those test data then go off to another performer, a different performer. They try to find the anomalies that we inserted. So we are playing a like question mark shot GAN game here. So this, when I moved to EXP, I didn't have any experience with like constraint optimization, but the way that the anomalies are given to us need to be solved with constraint optimization and mixed integer programming, which is something that I never learned. Like, I don't do computer, okay, I do data. But I am now, when I moved to EXP, I was like one of the core developers of the solution that we made. And I have now morphed. I was a little bit pushed, a little bit fell into it, becoming the product owner for this. So now I do less developy things, and now I tell the team of 2.5 what to do, like the code, the capabilities that we should be developing so that we can try to play this game of anomaly insertion to avoid detection, as well as developing our own anomaly detector model, which is a transformer-based LLM, to detect anomalies inserted by other companies and then forwarded to us, right? Two sides of the same thing. So like, I didn't know anything about constraint optimization, but I learned very quickly. And like, this is not the anomaly insertion part isn't AI, but the anomaly detection part is. So like, it's just, I have become I went from a depth first person in the PhD program to a breadth first person. And kind of like it, it's fun. Being a PO, product owner, I get to tell the computer science people that they're doing computer but not data, and we need to do a little bit of computer and data. Like the computer scientists, bless their hearts, they're like they're very good at writing good code, but but they somewhat lack the perspective of having dealt with data, and like they're much better at making things run fast than I am. So that's what they're for. Also, we're hiring, but subject to the constraint that right now we are looking for experienced people with clearances. But if I have piqued your interest in any way, I'm happy to take resumes or whatever, take emails, because you never know, we do sponsor. And I'll take any questions from that. I'll leave it on this one, because this is more interesting.
Here we go.
About the transformer, how do you discretize? Do you discretize locations? Are those the words?
Yep, H3.
Wow.
Uber has a library called H3.
Oh, cool.
It's 12 many different levels of resolution. At each level, there are 12 pentagons and the rest are hexagons.
Okay.
All covering.
And two words that are two locations that are next to each other, they're just two words and the transformer learns that locality. Cool. Thanks. H3?
H3, yes. So Google has a library called S2, which does squares or rectangles. H3 does hexagons and then 12 pentagons at each resolution. It's a geospatial hash. Yeah.
Any more questions here in the live audience? Any questions online? Hearing none. Anyone else want to ask something here? All right, thanks again.
All right, we're just about done. I've just got a couple slides to share to wrap us up. A couple of closing comments here. And there we are. Hold on. There we go. So yeah, thank you to all of our speakers. Some are still on, some were here this morning. Thanks to our sponsors, the AAS and the AIP. And thank you to everyone here and on Zoom who came for ATDS 7. We will get the recordings on the website in the near-ish future when we get around to it. End of month is a good goal, but we'll see how that goes. I did want to point out, this is on the website, on the ATDS meeting, the schedule page specifically, but there are a bunch of other data, big data, technique, Python related stuff throughout the AAS meeting. There's a bunch of a few career things as well. The two I want to specifically point out because they are closely related to ATDS and the Employment Committee for AAS is the Beyond Academy panel, or career panel, which I think is in this room actually tomorrow afternoon. And then right after that, there's roundtable discussions for a wide variety of careers, more so than even just the folks on the panel. And the roundtables are down in the poster hall. And I am on the panel this year, so come hear me rant about stuff more career specific. And then last but not least, I'll remind people we are having our annual informal networking event over at Brass Tap, which is just like if you go out the main entrance of the Gaylord, like 2 blocks, it's right there. Check out the website, it is very nearby. So from 6 to 8 p.m. we should have some space reserved under my name, Jeffrey Silverman. Marcos and I will try and get there kind of early, and so look for us. Food and drink, both alcoholic and non, will be available for purchase. You know, pub food and some good-looking cocktails and beers, and some mocktails as well. So come on out, hang out, chat some more, sign up for the email list, check out the website, listen to the podcast, all that good stuff. And that's what we got. Yes, also on the website, on the schedule page at the very bottom, there is the recruitment corner, which I had a little snippet of earlier, that shows a bunch of our speakers and other folks that are interested in recruiting, whether they have specific open jobs or just sort of generically recruiting. If you want to reach out to those folks, their info is also on the website. And this deck of slides will also be posted on our website once I get a chance to do that. Anything else I'm forgetting? Ava, anything else I'm forgetting?
Can't think of anything, just thank you, everybody.
All right, yeah, thanks everybody. Have a good day, a good rest of your conference, and hopefully see you this evening at Brass Tap. Talk to y'all later.